Hi, welcome to the section 1 for notes measuring angles. So an angle is formed by two rays. Find my color here. With the same endpoint, the rays are the sides of the angle, and the common endpoint of the rays is the vertex of the angle. Okay, now I'm going to go ahead and draw the angle. So now here is a ray, here is another ray, here is the vertex, and I'm going to go ahead and put some points on here. So I'm going to go ahead and put a point A here. I'm going to put a B here at the vertex, and I'm going to put a C over here. And I'm also going to put a 1 inside of the angle. Now, there's different ways I can name an angle. If I want to name an angle by the vertex, by the letter at the vertex, I can call it angle B. It's a quick and easy way to name the angle, but you have to be careful. You can only name it angle B if there's only one angle at that vertex. If there's more than one angle at the vertex and you said angle B, then someone would have no idea which angle you were talking about. So then you would have to pick a different option. The second option here says by a point on each ray and the vertex in the middle. So I can use 3 letters to name an angle. I do need to make sure I put the angle symbol in front. So in this case, I could call this angle ABC. Okay, I want you to think of another way that I could name this angle with 3 letters that would be an appropriate answer as well. And that would be angle CBA. But it's very, very important that you put the B in the middle, the vertex in the middle. And then you can also name an angle by its number, the number right inside the angle. So in this case, I could call this angle 1. And there's not always going to be a number inside of the angle, but if there is, then that's just a quick, easy way to name the angle. Okay, now a couple definitions. So the first one is interior of an angle. I want you to think about what the word interior means in everyday life. I think that's helpful in geometry to often think about what the words mean in everyday life. I like to jot that down, and then a lot of times that will help me remember the geometry definition of it. So interior means inside. You may have thought of like an interior designer, then fixes up the inside of the house and makes it look really nice. So the definition here is the region containing all of the points between the two sides of an angle. Okay, exterior, go and think about what that means in everyday life. The word that comes to mind for me is outside. I think of if someone says they're going to paint the exterior of their house, that means they're painting the outside of their house. Definition here says the region containing all of the points outside of the angle. Okay, for example 1, I think it's a good idea if you pause the video here and try to answer part A and part B based on what we just talked about. I think it's good practice for you. And then you can start the video again to check your answers. Okay, so welcome back. Hopefully you tried example 1. And on A, it says list 2 other names for angle 1. So I could name that angle JMK. Okay, or I could name it angle KMJ. Okay, I do have to make sure that M, that vertex, is in the middle when I name that angle so that you know which angle I'm referring to. On B, it says, would it be correct to name any of these angles angle M? And again, think about that answer. Hopefully you've already tried it. But in this case, the answer would be no. And it says to explain. It's really important in geometry if we ask you to explain or justify your answer that you communicate what the reason is. You don't want to just say no if it says explain or justify your answer. So I want to give a reason. And, your reason may not be the same exact as mine. You might word it a little differently, but you need to be clear in what you're saying. So I said that no, there are 3 angles that have vertex M. So if I just said angle M, you would not know which one I'm referring to. If I was referring to angle JMK, which is angle 1, or KML, which is angle 2, or even this big angle, angle JML. So if I said M, you wouldn't know which one I was referring to. Okay, so let's go ahead and get that moved up and go for the next part. So the next thing it says is to indicate the measure of an angle, write a lowercase m in front of the angle symbol. In the diagram, the measure of angle A is 62, written as the measure of angle A is equal to 62. So just like we talked about with segments the other day, there's kind of a technicality of when to use an equal sign and when to use a congruent sign. In this case, it's telling you if you want to refer to a numerical value of an angle, you're going to use an equal sign and you're going to put the little m in front. Okay, if I just wanted to refer to the angle itself, I would just call it angle A. And then there's 4 different types of angles here. You're probably familiar with these different angle types. So see if you can fill in these blanks before, you can even pause the video and do that quickly. I think you already know the answers to these. But again, once you've tried that, let's go ahead and go through that together and you can make sure you have those filled in correctly. So right angle, the measure of an angle is 90 degrees. And you can actually see that in the picture off to the right. Again, that little symbol inside the angle, the little like part of a square or box, is the right angle symbol. So if you ever see that symbol, you will know for sure that that angle is a right angle and that it is 90 degrees, even if it doesn't have the 90 in there. An acute angle has the measure of the angle is less than 90 degrees. And in this case, you can see angle ABC is acute. It is something less than 90 degrees. Obtuse, the measure of an angle is greater than 90. And less than 180. So you can see that picture angle DEF is an example of a obtuse angle. It might be something like 130 degrees or something, and that would be obtuse. And then a straight angle, the measure of an angle is 180. And basically, a straight angle forms a straight line. So I know that from here all the way to here is basically halfway around the circle, which is 180. Okay. All right, we're moving right along. We're to the second page. A lot of this set of notes is very similar to the segment information we talked about yesterday, or that we talked about in the 1-3 notes. May not have been yesterday for you, but in the 1-3 notes. All right, so the next thing talks about congruent angles. Again, you see that equal sign with the squiggly on top. Congruent angles are angles that have the same measure. Okay, so the same measure, or I guess I don't really want to say length for like I did for the segments, but I can just say the same measure. Okay, so it says if the measure of angle A is equal to the measure of angle B, then I know that angle A must be congruent to angle B. Okay, and if angle A is congruent to angle B, if that's something I know, then I therefore know for sure that the measure of angle A must be equal to the measure of angle B. Again, if I'm using the equal sign, then I'm going to have the little m's in front of the angles. If I'm using a congruent symbol, I don't have the m's in front of the angles. All right, next thing says angles that are congruent are marked with the same number of arcs. You can call them arcs, or you can just call them marks like we did on the segments. Number of arcs. Okay, so, if I see one arc and one arc in the angles, then I know those two angles are for sure congruent. You might see angles that have like 2 mark, 2 mark, and you would know then that was congruent, or 3 mark, 3 mark. Okay. Now we have the angle addition postulate, just like in section 1-3, we have the segment addition postulate. I told you, segment addition postulate was going to get used a ton in geometry. Same thing with angle addition postulate. It's the same idea. It says if point B is in the interior, or like we said, inside of angle AOC, then what? So I want to write a true equation based on this picture to the right. Okay, I know that I can see that angle AOC is this whole big angle. And I can see there's two little angles within the big angle. So similar to the segment addition postulate, I can say that the two little angles have to add up to the big angle. So that's just what I need to say in here for the equation. If I name one of the little angles, I'm going to use 3 letters since there's more than one angle at angle vertex O. So I'm going to say angle AOB. If you said angle BOA, that's fine. And now I'm going to say angle BOC. If you write angle COB there, that's fine. Just make sure the O is in the middle. And that has to be equal to the big angle, which is the measure of angle AOC. Okay. So I would like you to try example 2. See if you can look at that. It's similar to the segment ones, like I said, that we did yesterday. I would label the picture if the picture is not labeled already. And then I would see if you can set up a true equation and then solve for what it is asking for. And then you can jump back on and see how you did on that. Let me move this up and I'll keep going. All right, so hopefully you tried it and then you can go ahead and check how you did on it. If I was labeling this picture, I can see that some of the information is already marked on the picture for me and they didn't even tell it to me in the problem, but I can use the picture. But they did give me an important piece of information in the problem that the measure of angle RQT is 155. So if I look at the picture and find RQT, that's actually telling me that this whole angle from here to here is 155. So again, I need to think of a true equation to write so that I can solve for x. And again, I can say the two little angles, 4x minus 20 plus 3x plus 14 has to be equal to the whole angle, which is 155. Even though the problem is not asking me to solve for x, then I still need to solve for x. So I set up my true equation. I can now solve for x. I see I've got 4x and 3x. I can combine together to get 7x. I've got my negative 20 and my 14 that I can combine together to get negative 6. And then I have that as equal to 155. I can then add 6 to both sides, so I get 7x is equal to 161. And if I go and divide by 7 on both sides, I get x is equal to 23. Okay, once I figure out what x is, I can plug back in for what it's asking me for. So I can see that the measure of angle RQS is equal to 4 times 23 minus 20, and that gives me 92 minus 20, which gives me 72. So measure of angle RQS is equal to 72. Okay, and then I can go ahead and plug in for measure of angle TQS, and so I've got 3 times 23, and I've got plus 14, and that's going to give me 69 plus 14, and that's equal to 83. And then remember, like we talked about with section 1.3, see if you can think of a quick way to double check to see that you did all that work correctly. So measure angle TQS is 83. And again, a quick double check would be just adding up these two angles, 72 plus 83, and making sure that that gives you 155, which is what we said the whole angle should equal. And it does, so that checks out right. So again, you're not required to check it, but I think it's a good idea because it doesn't take long to do. Okay, last little bit here is example 3. So again, I would like you to pause the video, read the question, and see if you can label anything else that might be needed on the picture and set up your true equation so that you can solve for x, and then check back to see how you did. So, okay, welcome back. Hopefully you tried that one and can check. So key thing here is sometimes people just look at the picture, they don't see any other numbers in the problem, so they don't really read the question, and then they're not really sure what to do, or they might even just try to set the expressions equal to each other, which you don't want to do in this case. But they gave you some key information that angle DF is a straight angle, and you can also see it in the picture that it's two angles forming a straight line. So you should know from either of those that from here to here must be equal to 180. And I think that's helpful to label on the picture. Once you do that, the problem becomes basically just like example 3, like we just did a moment ago. Okay, so if you didn't have that already, go ahead and then you can go ahead and fix your equation and kind of solve from there. And I'm going to pause the video, and then once I get it worked out, just to shorten the video a little bit, then I will show you what my work and my answer. Okay, so you can see I have it worked out now. I set up my true equation. I solved for x and got 14. I plugged back in and got angle DEC to be 142 degrees, angle CEF to be 38 degrees. And just to double check that I did it right, I did a quick check of adding 142 plus 38 to make sure it gave me 180. It did, so I know I'm done. All right, good job. I will see you back for the 1-5 day 1 notes shortly.